The question says that the rate of increase of its temperature, that means d theta dt, is proportional to the temperature difference. That means it is going to be k of the temperature difference, which is 20 minus theta. And since the question says that d theta dt, it is a rate of increase, that means k over here, I'm going to let it be a value that is positive. And the question also told us that initially the temperature of the liquid is 10 degrees Celsius and the rate of increase is 1 degree Celsius per minute. Which means that initially, that is when T is equal to 0. When T is equal to 0, theta is given to us as 10 degrees Celsius and d theta dt is given to us as 1 degree Celsius per minute. If I were to substitute this back into here, that means this is going to be 1 is equal to k of 20 minus away theta. Theta is equal to 10, which means that k over here is going to be equal to 1 over 10. So the differential equation that we have is d theta dt is equal to 1 over 10 of 20 minus theta. And we are supposed to solve this differential equation and showing that it is equal to theta is equal to 20 minus 10 e to the power of negative 1 over 10 t. So to solve this, I'm going to make use of the fact that it is a variable separable. So I'm going to shift this over to the left hand side, which means that I'm going to get a 1 over 20 minus theta of d theta dt is equal to 1 over 10. And if I were to integrate both the left and right hand side with respect to t, I'm going to have a 1 over 20 minus theta of d theta here is equal to 1 over 10 integration of 1 of dt. So integration of this is going to be negative ln of 20 minus theta. Integration of this is just simply 1 over 10t, and I will add in an arbitrary constant. I'll let it be a. I'm going to try to make theta the subject. So ln of modulus of 20 minus theta is minus 1 over 10t minus a, which means that the modulus of 20 minus theta is going to be e to the power of minus 1 over 10t minus a, which I can also rewrite it as e to the power of minus a, e to the power of minus 1 over 10t. And if I were to remove away the modulus, it will be 20 minus theta is plus or minus e to the power of minus a, e to the power of minus 1 over 10t. And plus or minus e to the power of minus a, I will just let it be, let's say, b. So 20 minus theta will be equal to b e to the power of minus 1 over 10t. Making theta the subject, theta is going to be 20 minus b e to the power of minus 1 over 10t. We are almost there. We just need to solve for b, probably showing that b is equal to 10. And to solve for b, I'm going to make use of the initial condition again. Initially, the temperature of the liquid is 10 degrees Celsius. That means when t is equal to 0, theta is equal to 10 degrees Celsius. If I were to substitute it into here, that means 10 is equal to 20 minus b e to the power of 0, which is 1. So b over here is going to be equal to 20 minus 10, it is 10. That is why theta is equal to 20 minus 10 e to the power of minus 1 over 10 t.